some of the questions related to relativistic mechanics from classical mechanics. Theory of relativity you have studied. So from that I am going to solve some problems here. Before going to start, if you are new to my channel, please subscribe my channel for upcoming videos. So here is the first question. The two events separated by a spatial distance 9 into 10 to the power 9 meter are simultaneous in one inertial frame. The time interval between these two events in a frame moving with a constant speed 0.8 c, where the speed of light c is equal to 3 into 10 to the power 8 meter per second is. So here are the two events they have given. So first we should write down them as x1 and x2 prime, and they are separated by a small distance 9 into 10 to the power 9 meter, and the time related to time interval between the two events is going to be constant. So if we take the difference between them, just we can equate here. First we should know what is the relativistic time equation. In general we can write, if we take t2, that is t2 prime plus v divided by c square x2 prime root of 1 minus v square divided by c square. This is the general formula for relativistic time. So like that we have to write t1 prime, then t2 minus t1 we will write in terms of t2 prime and t1 prime. If we take t1 and t2 prime, we should write in terms of t2 and t1. Okay, so here we have taken the difference between, or the interval between two events. So if we equate t2 minus t1, so finally after taking LCM we will get this v divided by c square x2 prime minus x1 prime. So they have given here they are separated by a distance 9 into 10 to the power 9 meter. Just substitute that, and speed of light they have given. If we substitute and they are moving with a constant speed, velocity 0.8 c. After substituting value, the time interval between the two frames we will get 40 seconds. So the correct option is B. Muon has mass of 105 mega electron volt per c square and mean life time 2.2 microsecond in its rest frame. The mean distance traveled by a muon of energy 315 mega electron volt before decaying is approximately. So here they have given actually this once we read we think like this is related to nuclear physics, but here in terms of relativistic dynamics we have to explain. So they have given the energy, that is 315 mega electron volt, and the rest mass is how much here? 105, that they have given here muon rest mass in terms of mega electron volt. Then Einstein's energy mass energy relation is equal to mc square. So according to that, if we substitute relativistic mass, formula for relativistic mass is what? m naught c divided by root of 1 minus c square v square by c square. So once we substitute here relativistic mass equation, they have already given energy, and then rest mass is how much? 105. Just substitute values here, so you are going to get the velocity or the distance traveled. So velocity how much here? 0.94 see that not we have to find out here the decay, that means time, how much it has taken. So relativistic time t naught divided by root of 1 minus v squared by c squared. So t naught, how much they have given here, 2 point lifetime, mean lifetime microsecond. Just you have to substitute values here, t naught and v velocity, then you are going to get the time. The distance traveled by the muon is how much here, that you should do it by multiplying velocity into time. So time is 6.6 microsecond. If we multiply, we will get the distance traveled by muon. So 1.86 kilometer. It is near to option D. So the next question, the area of the disk in rest frame S is equal to 1 unit. The disk will appear distorted to an observer O moving with the speed u with respect to S along the plane of the disk. The area of the disk measured in the rest frame of the observer O is, so they have given here 4 options, so we need to verify the answer. Area of the disk from S frame means 1 unit, that is area how we usually measure pi r square. So pi a square we can take, that is equal to 1 unit. Pi, if we just take the multiplication of pi a dot a is equal to 1. Then area of the disk from another frame S prime frame is pi a dot b we can take to differentiate the frames. Just equate here pi a dot a root of 1 minus u square divided by c square. You are going to get here answer. Then how we can relate it to A and B, area of or the disk, that is what radius A and B. So B is equal to A times root of 1 minus u square by c square. So here option A is going to be correct, plus root of 1 by 2. Here minus first option is correct. Consider 3 inertial frame of references A, B, C. The frame B moves with the velocity c by 2 with respect to A, and C moves with velocity c by 10 with respect to B. On the same direction, the velocity of C as measured in A is. So here we have 3 frame of reference. B moves with respect to A, C moves with respect to B. In the same direction, the velocity of reference frame of reference C and A we have to calculate here. So you can see in this figure S prime, X prime, A, B, C, 3 frame of reference. So velocity is how much here, c by 2, moving with the velocity. So here the initial velocity is what here, c by 10. For frame of reference C. Then we have the formula here to calculate the velocity of the two frame of reference relative velocity u x prime plus v divided by 1 plus u prime vx divided by c square. Just substitute value of v and ux prime here, we will get ux. The velocity of c as measured in A is 4 c divided by 7. Option B is correct. So another question, let two frame of references with coordinates x comma t, x prime t. The coordinate system used by the observer O and O prime respectively. Observer O prime moves with a velocity v is equal to beta into c along their common positive x-axis. Okay, if x plus is equal to x plus ct, x minus is equal to x minus ct are the linear combinations of the coordinates, the Lorentz transformation relation relating O and O prime takes the form. So here we have two transformations relating to the observers O and O prime in terms of coordinates x comma t and x prime comma t prime. So first we should note down here x plus prime. So what is the equation here? X prime plus ct prime. Just substitute x prime for in case of relativistic dynamics x prime and value of c as it is time, relativistic time. Then if we equate these two after substituting value of x prime and t prime, here we will get the final equation, that is root of 1 minus v divided by c 1 plus v divided by c into x plus ct. So here v by c, as we know, velocity is related to beta into c. So beta is what? V by c. So that means x plus prime is equal to 1 minus beta divided by 1 plus beta x plus. Next we should evaluate for x minus prime. So these are what? Linear combinations of coordinates. Then if we do the calculation for x minus prime, we again going to have the equation in terms of beta, that is 1 plus beta divided by 1 minus beta x minus. So here option D is correct. Lorentz transformation relating to O and O prime, which takes the form.